Hello, my name is Keval and I'm here with my friend Triven Tandel. We are going to present the biological hazards. The introduction, biological hazards or biohazards refers to pathogenic microorganisms such as bacteria, viruses, fungi, and the parasites that poses a significant risk to the human health. So we have like biohazard safety levels which are distributed into four parts, one, two, three, and four. So biosafety level one contains organisms which are dead or pathogenic bacteria which are not able to cause any kind of disease, which are certainly did, and we can study on that. In the biosafety level 2, the students are like the laboratories which are located into the college premises or in a university level in which they can study about the microorganisms growth or certain bacteria which cannot contain a certain or a fatal or a fatality kind of risk to the human health. In the biosafety level 3, the certain microorganisms and the bacteria can cause a health disease, like can cause a disease, but it's not that much uh, kind of threat or cannot kill any person. So it contained in level 3, but still it can poses a certain risk to the human health. In the biosafety level 4, the highly uh, like contained laboratories in which they are working on a research as well as they are working on a certain bacteria or pathogenic organisms which can create a pandemic or epidemic, or can cause a death to a person. So these laboratories are located on a certain designated areas which are far from the city or far from the human population, so they can work easily on that microorganisms. So basically, these hazards are particularly prevalent in high-risk environments such as healthcare facilities, laboratories, agriculture setting, and food production industries. Exposure to the biological agents can lead to infections, allergic reactions, or a toxic effect, underscoring the importance of effective hazard in identification, prevention, and control strategies to the protect workers and the general population. So here's the first question. How does the antimicrobial resistance, AMR, it's short form of the antimicrobial resistance, exacerbate biological hazards in healthcare settings? So antimicrobial resistance means that the common pathogen have a no longer respond to the first line of antibiotics, which means the organisms have like certain uh, particular traits, or like they can do a DNA mutation, they can have a like biofilm formation, they can have a sense of memory, so they can create a uh, kind of layer or certain resistance to a particular chemicals by overusing of antibiotics, that as well as they can transfer their gene from one bacteria to the another bacteria, so they can have a like resistance to a liquid that we are using or chemical that we are using to just kill that particular bacteria, so undermining this treatment of routine infection and complicating life-saving procedures like chemotherapy surgeries in healthcare settings. AMR leads to longer hospital stays, higher morbidity or mortality, and increased risk of outbreaks of superbugs amongst patients and staffs. So basically, microorganisms have a sense of memory, so they can form a biofilm, which is a kind of thin layer, and it is hard to break through antibiotics or any kind of chemical. It should be removed through like a hard scrub or hard wash, so it can leads to a touch of the human skin and can cause a disease. So these are the threats because of the antimicrobial resistance. The second question is the what impact does the climate change have on the emergence and spread of biological hazards? So climate or biological hazards can be affected by the climate change, like effects on biological health of soil, reduced soil organic matter and fertility status. Then after increasing weed growth and disease outbreak, sanitization or salinization, alteration in nutrient dynamics. So, a rising temperature is the mean point, and altered precipitation patterns expand the geographic range and seasonality of vector-borne disease like malaria, dengue, and Lyme by increasing the vector survival and breeding sites. So, rising of temperature and the creating the droughts and the rising in water level can create a certain environments for the vector-borne mosquitoes or any kind of vector which can carry on the pathogenic bacteria or microorganisms from that certain favorable environment and can grow easily on that environment, and they can also survive through the extreme weathers, floods, droughts, and also degrade sanitation, leading to a water and foodborne outbreaks as they are favorable to that conditions. Overall, climate change has already aggravated 58% of known human infectious disease and projected to increase both frequency and the scale of biological hazards. It means in overcome upcoming time period, it the infectious disease can be grown in both frequency and scale of biological hazard events because according to that the favorable conditions are increasing in day by day, so that can have the ability to give a particular environment to the organisms to grow on them, feed on them, and they can break out through the vector borne like mosquitoes which carry malaria, dengue, like that. Here's the question three. What are the economic costs associated with the major biological hazard outbreaks? So it's like pre-emergence, pathogenic spillover, emergence, localized transmission, and epidemic. So these are the model of bioterror or pandemic scenarios. Estimated the direct medical cost and the lost productivity ranging from 477.7 million to 26.2 billion per 100,000 exposed person. For example, brucellosis versus anthrax, a severe influenza pandemic in the US, could incur 71 to 166 billion dollars in the healthcare and societal loss. Rapid prophylaxis and preparedness measures, stockpiles, vaccinations are economically justified to avoid this high cost, but it is hard to detect upcoming outbreaks that we know, like in the recent times we have been passed through the COVID, which has created a lot of economic health, and economic sector has been gone down because of this thing in worldwide, and it is hard to get early detection and containment. So basically we can do one thing: controlling and mitigating these things while just doing a widespread testing, quarantine, scale up the healthcare, school, and business closure, as well as we can just do the primary preventions like reduction of deforestation, agriculture, and wildlife trade. So these are the certain measures we can take to just decrease these outbreaks, and we can just have like we can have a certain time to study on that upcoming bacterias. Here's the fourth question, and it's gonna be explained by my friend.
Hello, friends. My name is Triven Kumar, and I'm partnered with my friend Keval Patel. So let's move to the fourth question. So our fourth question is: how can genomical surveillance be used to detect and respond to emerging biological hazard? The genomic surveillance is the system or surveillance, a kind of the metaphor for to detect the RNA and DNA from for biological hazards. It can provide an early warning system, kind of, and detect new variants of biological hazards before they were spread widely. The program like a CDC Traveler, it can, based to genomical surveillance, have identified multiple SARS-CoV-2 Omicron subvariants at the US before the COVID spread widely and enormous, make the pandemic all over the world, and it's totally disaster for all over the world. So the genomic surveillance is the best system uh, we could get that this kind of like pandemic. So the genomic surveillance uh, is the system that analyzes the similarities and differences for different biological hazards. It can monitor disease, it can control the pathogens, it can also tailor the inventation and the recommendation of for the public, like the public sectors, where the so many people are gathered, like airports can count railway stations, also food market, and any other places where the people are gathered. So, and it can also develop the countermeasure like vaccines. It could be a very helpful when pandemic hit on the world. So the genomic surveillance system, it's the best for humanity, and it's also stamp out the disease. Uh, it's not 100% all the time, but so yeah. Then let's move to the fifth question. How can climate and geography influence the presence of biological hazard and different workplaces? So the biological hazards, it can spread widely different places to different regions, like where there are so many places like tropical and subtropical, for example, Brazil, Venezuela, where can the big forest, rainy forest, and there are big swamps, where can the parasite enormously growing and growing in the dirt. So yeah, so those are the places where uh, the mosquitoes which are can transmit to Zika, malaria, and dengue kind of uh, the disease, and also in a northern or where the temperatures slowly down, they may see more exposure to the ticks and also associate risk of Lyme disease, particularly in forest area. And also the other part of higher humidity levels in areas, there are certain environment can also promote the growth of mold and fungi, posing a risk of indoor air quality, where the farmers are get more and more disease because of the humidity, because humidity is influence the big impact on mosquitoes and um, other uh, insects. Those are cause for biological hazards, and it's potentially very risky to environment and the reasons for different part of the region. So let's move to the our recommendation, few recommendations which are come of it. So the first one is strengthen the biological surveillance system, as I mentioned before, which the biological surveillance system is a very helpful throughout the whole pandemic uh, whole pandemic time period, and the government should implementing more and more uh, the departments and officials which can prevent which can let the people know about the biological hazard, and which can teach the all those certain people those are not aware of the this kind of fatality or the disease, so they can provide the certain amount of information, also the certain amount of equipment system, so they can uh, we can prevent the outbreaks or kind of pandemic, the next pandemic. And the second was the addressing antimicrobial resistance through policy and innovation. So government should implement the strict policies and regulate the overuse and misuse of antibiotics in healthcare and agriculture. There, the where the government policy are weak, the so many industries are they wasted their waste into rivers and to lakes, and people are those lakes there people are using the water in the daily regular basis. So yeah, it can be a potential risk for those people. So government should uh, implement a strict regulation and policies for those kind of sectors or private companies. The third one is integrate climate resilience into public health planning, same as I explained. the government should implement the different department to different reasons uh, to respond to climate related biological hazards. It include expanding vector control programs, improving sanitization systems, like provide a proper sanitization or biological prevention systems like a PPE, and also where there are highly risk area, uh, government should restrict the area and prevent the area by looking after studying after the whole scenarios, and also implementing the good implementing a good sanitization and for the public and the places. And the fourth one is enhance public awareness and this communication. The awareness to spreading the awareness and communication is a very crucial part of the for the prevent the pandemic kind of risk. So, the targeting education campaigns, and also there are medical expertise. Those are the people who can understand the biological hazard very well, so they can go to those places and teaching to the locals how to prevent and how to learn about the risk, so they can monitor the risk timely, and also adapt the local culture and context to build the public relationships and improve the compliance. And the fifth one is invest a long-term preparedness and also emergency response. So establish and maintain the national stockpiles of vaccines, uh, personal PPE equipments, and also medical equipments. So the regular emergencies preparedness helps to ensure the healthcare facilities have a surge capacity for the certain areas and certain peoples. So governments should also fund the ongoing research in pandemic modeling and biosecurity, and also they could uh, they could hire a very knowledgeable expertise and the biological expertise, the doctors and the medical sectors. So yeah, they could help. Those people are help to build a good communication with peoples, and they could also very uh, they could also research about the places and hazards, so they can prevent before the spreading the biological hazards. So let's move to the
To the
conclusion.
conclusion, I will do the conclusion. For the conclusion, as we know, like biological hazards are, in short, it's available, like it's a kind of hazard which is surrounded by each and everyone. So it's in the environment, it's in the healthcare sector, even it's in the uh, in our houses. So basically, for the prevention, to take care of the or to minimize the healthcare hazard or biological hazard, we have to just do certain things, like we can just like remain persistent and evolving threat in the occupational and public health settings within the rise antimicrobial resistance, climate-driven shifts in disease patterns, and increasing global mobility. The complexity of managing biological risk has grown significantly, as I mentioned. So we can do certain things like we have to being keep to up to dated throughout the uh, certain disease or pathogenic microorganisms which poses a threat. So we have to get the knowledge for uh, we have to be up to date to that certain diseases, so we can just take preventions, as well as we have to make our surroundings much clearer and nicer, and we can just disinfect the work surrounding places, so we can just prevent the organisms or microorganisms which can cause diseases to us. However, Emerging solutions such as genomic surveillance, data-driven public health interventions, and strengthened community engagement for offer a proactive path for disease for the high basis for the high scale uh, prevention, so we can take certain measures for the kind of pandemic creating disease or certain disease which can out cause outbreaks to the certain countries and can create a loss of millions and trillions of dollars or in certain currencies, so that can have a like negative effect on both local and global levels. In summary, the mitigating the future biological risk lies only in controlling certain current threats, but also in anticipating and adapting to the those microorganisms which are yet to emerge and which can cause a disease in a future basis. And these are the references which we took help and we got a certain informations from these websites. Thank you.
Thank
And
you.
these are the biological hazards.
Thank
Thanks.
you so much, guys.